Hey, John here. Let's look at your first assignment number 0. I use the same one for all my sections this fall. So this one I'm using the Comp Sci 463 page. So if you're in 501 or another course and you have assignment 0, the instructions will be the exact same thing, except your course number will change. That's the only difference that you will see. So let's look and see how you do this thing, all right? First thing you need to do is set things up. If you don't know how to log in with SSH and you're stuck on Windows, you need to install PuTTY. I talked about that in the introductory video. There's a link back to the installation instructions right here in assignment 0 if you forget. If you've never used Hopper or Turing, here's a link to the instructions on how to connect to the first time. There are instructions in Blackboard. You should have received an announcement that told you here's how your password will be set the very first time that you log in to Turing and or Hopper. After that, you change it and you need to remember your password. If you forget it, send an email to John Berezinski or Kirk Duffin. For whatever reason, Kirk Duffin's email is not on this page. Send it to John. That'll be fine. If he's not responding, go open the course syllabus. Kirk Duffin's email is in there under the section on how to connect to Unix and set your password, okay? So in here, it talks about how to use PuTTY and stuff like that. So you can read this if you need to use it. If you're on a Mac or on Linux, you can just type in the SSH command like you're going to see me do it right here. All right, now, first thing you need to do is log into Hopper. This is my home system, so I'm going to type SSH, and let's say my Z number is Z1234567, right? I would type that in and then I would hopper.cs.niu.edu and type it in right, or it won't work. Now, obviously, that's not my login. My login's a little different than yours. My login is that one. So I'm going to type my login in. And I get in here like this, okay? You'll have to type in your password, and you might have to log in twice the first time. One of the things in here, I thought I mentioned it. I don't think I did. When you do it the very first time, okay, what happens is, very first time you log in, your login will look like it has failed, okay? The reason it does that is because it's not yet configured. Once it fails, the system will take note and realize that you're supposed to have an account. It will then create an account. So once you log in your first time using the password based on the rules in Blackboard announcement that you're going to get, the second time, wait 30 seconds and try it again, okay? Then it will succeed, all right? Okay, now I'm logged in. You can type the command clear like that. It'll erase the screen and get garbage out of your way. You can type ls that says list my files. If you're new to Unix, these are the standard commands. ls-l means give me a long or verbatim, or rather verbose listing. I prefer to see the files and directories named vertically stacked up like this rather than strewn across my screen like that, okay? Now, what are you supposed to do? This is the assignment. I'm giving you the answer. So type CD if you want to. You're already in your home directory. Anytime you type CD and you hit enter, it takes you to your home directory. If you type PWD, it says print working directory. And you're asking the system now to tell you, where the heck am I? And it says you're in home Hopper Winans. That's how you say this. You don't say /home /Hopper /Winans. Any real system user would know that you're new if you say that. You're in home Hopper Winans. That's how you say that. You would be in home Hopper Z 1, 2, 3, 4, 5 or something like that, okay? You can, again, like I said, I have a shorthanded ls commands as well, ls-l. I think if you type in ll by default, you will get a longer version as well. There's all kinds of customization and configurations you can do in Unix. I use a lot of shortcuts, and I've been doing this for decades, so I apologize if I use a shortcut in one of these videos that doesn't make sense to you. Definitely send me an email and say, what the heck was that, if it confuses you. I do it so much I don't even notice it, all right? So I'm going to clear the screen and go back here. Oops. All right, there we go. There's the simple way. All right, so what are you supposed to do? You're supposed to create a new directory. Again, I'm doing this for 463. If you're in 501 or 101 or something like that, you would put a different number over here, right? Why do you do this? You do this so that you're organized. Your stuff for your course goes in one directory. You don't strew your files all over the place. Again, that's for a newcomer that doesn't know what they're doing. By the way, if I put an LA in here, what that means is I want to see all my files, not just the visible ones, because A will show you the files that start with a dot, okay? Dot, this is an alias for, that's your current directory, okay? The dot dot is an alias for the parent of the current directory. So this right now is my home directory, okay? It says I've got a directory, I got a home directory. You always have to have these two files, otherwise you can't be anywhere if you think about it, right? You got to be here, and you have to have come from somewhere, all right? This down here, the prompt always shows the name of the directory you're in. The tilde is shorthand for my home directory. So again, if I type pwd, it says home hopper whinings. This whole thing in here, slashes and all, is shorthanded with tilde because everybody has this prefix. This is a nice way to not use 80% of the screen up, wasting all that with all this path that you already know and don't care, okay? So tilde slash 463 is the 463 directory in my home directory, and that's where I'm at right now, okay? Right there, okay. Now what are you supposed to do? I did a make dir, I did a cd into the directory, right? Yes, I did. And then I typed ls in there, and I typed ls minus al, and so on, okay? Now, if you don't know anything about Unix, and you just learned a ton about Unix from what I just told you, if that's the case, you need to go back and read about all this stuff, or you'll be totally disoriented and confused in this course. I'm going to assume you know what you're doing, and or can pause the video now and go read all this stuff and come back, all right? Now, this is just some example commands. If you log off and come back later, you obviously need to go back into your directory and so on, because when you log back in, you always start out in your home directory, okay? In fact, I'll go ahead and log off right now. I can log back in again, and you can see once again I'm in my home directory. And I can type it clear to get the noise off my screen. I can type ls minus l. It saved everything I was doing, so there's the directory I created earlier. And there is nothing in that directory right now, okay? So what are you supposed to do? We were trying to do an assignment. Make a directory for the assignment. Stay organized. Otherwise, you're going to have a giant mess on your hand. You're going to lose your files. You're going to delete them. You're going to copy one assignment over another one, create yourself a giant mess. And I cannot help you. Once you've deleted your files, they're gone. There's no garbage can, trash bin, or anything else like that. If you're copying files back and forth between your home system and Hopper or Turing, you need to make sure you remember where the latest, greatest versions of every file are so that you don't keep copying old ones on top of your new ones, all right? It's just very basic, simple stuff. And you would laugh at how, when it happens to somebody else, but when it happens to you and you just lose an entire day's worth of work because you weren't thinking, you weren't keeping track, you weren't organized, it is frustrating beyond comprehension. All you need to do is be organized, and the odds of a problem happening go down like exponentially less likely. Okay, so I got a directory called 463. Within that directory, I'm going to have an assign 0. Then I'm going to have an assign 1 for the next assignment, and an assign 2, and so on. And I'm going to keep all my stuff organized. So there's a place for everything, and everything in its place. Okay. At this point, we're ready to do the assignment, all right? Did I CD into it? Yes. Okay, so there's a bunch of commands in here. He talks about pwd and ls minus al, the stuff I just showed you, how to copy files around. You can do all that on your own. Read it, do it, know it, love it. If you're going to use a recursive remove command, this is instant, no forgiveness. Once you remove your files, they're gone. If you said rm minus r tilde, and I'm not going to even type it in to show it in here because I don't want to accidentally hit enter, right? If you ever do that and you hit enter, what you've done is told the system to recursively delete all files from your home directory down to every single thing you own. If you ever do that, you will completely devastate all of your work instantly, and it will not be recoverable. Okay? So I should probably remove that from this handout. Full disclosure, I got this from somebody else. This is a very handy command, but it can be very dangerous, right? It's very unforgiving, and you cannot undo it. Just don't use it until you know what you're doing, okay? All right, so what are you supposed to do? What we're going to do is we're going to type in one program, and we're giving you the source code here. This is it. Here's your entire source code for the first assignment. So you don't even have to think about writing code. This is about how to use the system, right? And the title of this assignment is lab training. So this is about how to use Hopper. If you've done this before, this is easy. It's 5 minutes. If you're not explaining it, you should be able to just hit this, paste that, and then hand it in. Okay, so here we go. If you don't know how to do it, follow along here. Nano is the easiest editor to learn how to use because it doesn't do much, right? It's incredibly cumbersome to use, but it's zero effort to learn. If you only learn anything, if you never learn how to use any other editor beyond Nano at the command line, it's probably a massive mistake. No real programmer writes their code with Nano. Anything would be more useful than Nano. The only reason we even have it, and the only reason I mention it or even show it in this video, is because I don't have to explain anything at all. You're on your own to teach yourself the more advanced editors, and I mentioned that in the introduction. There's links on how to use the editors, that the big kids use, right? All right, so we opened up an editor. We got to get this text in there. You could foolishly sit here and try to type it all in, or you can copy it out of your web browser and paste it into the editor like this without making any mistakes. So if I scroll up, I can see it's all in here. And if you read the, it's a VI command. I'm used to using a much better editor than this. If you read the syllabus, you know that you're going to lose points if you don't fill in this properly. So part of this training exercise is to make sure that you actually know what you're supposed to do. So you're supposed to put your author name in there in the assignment, in the class, and stuff like that. Here's the code. We give you the code. Now, this code is actually not documented. So in theory, this program would lose 20%. It's great for documentation. There really should be a doc box in here, is my point. And I mentioned that in the introduction video, but I'm not going to write one. In this assignment, it will not matter. I will not take off for doc. In this assignment, the only doc you need is this. Put your name in here. If you don't do that, if you can't put forth at least that much effort, then there's something wrong, okay? So here's an entire training for Nano, all right? Here are your commands. These is basically the command line version of a menu. Remember, this stuff was written 40 years ago. Where all you had was a terminal that looks like this black window here. You didn't even have color back then. It was literally, green on black, and that's what you got. Anyway, the point is this little up arrow thing means hold down the control key and hit the letter O to write out your file. I don't know why they didn't call it save, which would make a far more sense. So I'm going to hit control O, and it says, hey, do you want me to save this in labtrain.cpp? And I'm going to press enter to say yes, okay? And then it'll tell me I wrote out 29 lines and all this other stuff. I can now hit control X to get out of here. And there's a help screen. They probably have more commands and stuff like that. I've never used Nano in my life other than to do demonstrations like this for students. So that's all you need to know about Nano. The control O and the control X, and you're done. Use the arrow keys to move around and type over, the old text to replace it. That kind of thing. Really, really dumb, simple. Now, move on to here. And we give you the one single command you can use to compile this file, and hopefully I pasted it in right. Yay. No errors, no warnings, okay? If you type in ls, one form or another, you see here's the file that we created. There's the text file, lab train. My ls, I have it set up so that it puts a character at the end of the file name if it's special in some way. This one has an asterisk after it because it's executable. And again, if you read the Unix information, these letters over here tell you things about these files. The fact that there's a D here means that's a directory. The fact that there's a D here as well, means that this is a directory. The fact that there's an X on this line here means that's an executable program. There's no X on this one means this is not executable. The RW means that I am allowed to read and write these files if I want to. So this one's executable, so let's go ahead and run it. And remember, the asterisk and the slashes are not part of the file names. The ls command just puts those on there for me. I do not believe that by default, I don't believe that your ls will do that, okay? So I need to point that out. Mine's configured a little differently. So when we run the program, if you spent any time paying attention to what it actually does, and I did not, we have to go back and see what they... So we're supposed to type in our first name. It's going to read the name and store it in a variable called name, and this is the worst practice on earth because this is a buffer that is 50 characters long, and you could probably overwrite it and cause problems, but... This is an example that's about how to hand in a program, not how to write a good program. This is kind of, I should probably change this so that we're not giving you bad techniques. Anyway, don't worry about it. This is the thing you're supposed to hand in. So it reads in your name, and then it says hello, such whatever your name is, and then it exits. Okay, so let's go ahead and type in blah blah blah, and it'll say hello blah blah blah. Now just let's have some fun. It said what was it, a 50 character buffer for the name? If we write more than 50 characters, now in theory C++ can know that array is only 50 characters long, but I don't think it cares. So if I store too much in there, I might kill this program. Oops, I didn't run it right. I'm supposed to type my name in now. I didn't type it in right before. So that's about, let's go ahead and store tons of X's in there. All right, so here's a whole, this is 10 times more than it's going to be able to hold. Let's see what happens. And we get a segmentation fault. So yes, this is a wonderfully bad program, but it does work for our purposes. All right, oops, if you actually run it right. John, hello, John. Okay, now I'm in assignment 0. Okay, be it as it may, I'm laughing because it's like, this is so bad. We should not give you this. Never give a student an example of a bad program. So if this is your first time ever writing a C or C++ program, forget you saw this after you handed it in. All right, just delete it and move on. Next semester, I'll rewrite this so that it's not as poorly conceived as this. Okay, so moving on. Pardon my digression. Moving on. So normally you don't type this giant thing in every time to compile your program, and this is only useful anyway if your program is constructed out of one single source file. No useful program, I think, in the history of time is written in a single file. Usually there's multiple files, usually hundreds if not thousands of files of anything that's really truly worth getting paid for. So you need to manage these things with a bigger view towards project management in mind. So there's a system called make, and you can create a file called makefile, and we give you one. So let's do the same thing and paste in this right here, which is a makefile. It's not the worst way to write a makefile. We'll talk about makefiles at some point during the semester. For now, just take it, run it, use it. The short of it is that you have these rules. You can sort of see in here, here's G++, right? And there's a variable here. Instead of putting all this on the one line, we assign this bunch of stuff to this variable called CXX flags, and we put it in here. So this is really going to do the same sort of thing. This is going to use 2 steps instead of 1, because normally when you have multiple files, you have to use many steps to do this. So this is kind of the minimal makefile that you would use to start a new project that you expect to grow into having multiple source files. All right. So I'm going to hit Control O, and I'm going to hit Enter to save it. Then I'm going to hit Control X. And I can now see I have my makefile sitting here. I'm going to remove this file here like that. And I'm going to run my makefile. And to run a makefile, you simply type make. Now, make will look around and find if there's a makefile sitting around here. And if there is, it will read it. It will find out how it's supposed to recreate its target that you want to create. So it looks in there, and there's a rule that says I can convert labtrain.cpp into labtraincpp.o, and then I can convert labtrain.o into labtrain. This is called an object file. There will be some reading material and in your courses usually. Hopefully by now you know the difference between a source file and an object file and an executable. If not, this course should cover that at some time. So let's go ahead and run it to make sure it still works. Yay, it still works. And you can see in here, we now have not just labtrain, but the object file, the make file created, okay? Now inside here, it tells you here, run the command that says make and so on. It gives you this note about if make says there's a missing separator and it stopped running, that means that when you put this in there, you did not put a tab character here. You see, if I move my mouse around, I'm like trying to copy stuff off the screen here, and the mouse kind of leaps around, one for each character, right? Well, let's what happens if I move to the left from right here, one character at a time, and all of a sudden, pow, it's not going to highlight anymore until I get way over here, and then all of a sudden, it's one single giant wad, okay? That's because this file on the web browser has a tab over here. There's not a bunch of spaces here. That's a tab character, okay? When I copied and pasted it into, Nano, it copied all of this as a tab, okay? So that's a tab followed by G++. If you don't do it right and you put spaces in there, is my point, it will say, I don't know what to do because the tab character is actually part of the make language. And it'll say missing separated. And then we mention in here, that means you did not indent it right, okay? So that's what will happen. We just ran it again after we did a make. When you're done, you type make clean like this. Get rid of your junk, okay? Make clean should clean out everything that make can recreate if you want. So you want to get rid of this stuff because they waste disk space, right? These are trivial little program. So these are only tiny, 17K, and this is only 3K. It's not wasting a lot of disk. But normally any real usable program will be hundreds of K, if not megabytes, okay? And you have a quota. You're going to run out of your quota if you don't clean up your mess after each assignment. You can leave the source code around because in this particular project, there's only 449 bytes in labtrain.cpp. That's not a lot of disk. That's not a problem. The make file that we typed in there was only 245 characters. These don't use a whole lot of disk space. You can leave these around. You don't want to leave your executables around, all right? Usually these will be in multiple megabytes, okay? So if you run out of quotas, just go back and clean up your old projects. That's the whole point there. It's also important for you to clean your mess up before you hand it in. If you log off and log back in, you need to change the directory back down and make sure that you clean up your file. CD ... Remember, ... is an alias for go up to the parent directory, right? So I just typed in CD ... Notice the prompt here changes. So now I'm in the parent directory of where I was a moment ago. If I type ls, I see assign 0 in there. I can type ls, and then I can type assign 0 like this, and I can see what's inside assign 0. If I want to, I can type ls minus al assign 0, and I can see the long version, right? If you don't know Unix, the arguments that go with a command go along with the command over like this. So like ls assign 0, you would not say ls assign 0 minus al. No, you have to say ls minus al. The options to al go before the name of the thing you want to list. All right, this is very common convention, okay? Anyway, so again, little review of ls there. Once you're done and you've cleaned the whole mess up and you're in the directory, where you can see assign 0, not in assign 0, but in the parent of assign 0, you can type in MailProg 463 or whatever your class is. You might be in MailProg, for course 501, it will be MailProg 501. If you're in 101, there will be a MailProg.101 and so on. Use the right MailProg for the class that you're in. Otherwise, it goes to the wrong TA. You get a 0 if you send it to the wrong place. Don't blame me, okay? Type in the right thing. So I'm going to mail assignment 0 to the TA and the instructor for 463. And it's going to say, don't use this for just sending email around. I guess that's a warning for students in the past that had absolutely no idea what they were doing. I can't imagine using this mail programs. I don't know, whatever. So this is only to hand in your assignments. You're not going to be able to type a message in. You want to type a message in? Use regular old email, okay? So it's going to ask, what's the program number? Well, this program number is 0. You put the wrong number in there, we're not going to get your program, and we're not going to be able to grade it. You make a mistake, it's on you, not on us, okay? Follow the instructions, read the rules, know them. If you screw it up and type the wrong number in here, just do it again and put the right number in there, okay? Then what happens? Well, you basically are done. If you get an error or something like in here, then it didn't work, and fix it, okay? Like you type mail program and like, let's say I did something foolish like this. When I type in XXX, it's going to say, oh, XXX is not a directory I can mail in there. Give me the right one. All right, use your wits. Read the messages that come out of here before you waste, 3 days trying to track down a TA to read you this error message. All right, read your error messages. Okay, then what happens? If you read the submission instructions and you scroll to the bottom here, this one tells you a lot about a lot of stuff. Here's like an example session. If your class is more than one section, you might have to type in the section number. In the demo I just did, there are no, everything is in one section right now for 463. When you're done, if you want to, all right, you can run the command line mailer. And you can see if it gave you a carbon copy of your homework. This only goes to the mail system on Hopper and Turing. It will not go to your student email. It doesn't go anywhere else. It stays on the local machine. If you type mail, you should see a copy of the program that you just handed in. So in this case, it would say, homework comp sci 463 program 0. I don't know what it would say for this section. It'll probably say section 1 or whatever the default is, okay? If you had a section and you typed the section number in up here, then this number here would reflect the section number down there, okay? If you see this, then it definitely went through and it worked, all right? I've never known there to be a problem other than, as long as you don't get an error down here like this, it's not an error. Where's the error? Here it is. As long as you don't get an error like this, it works. Okay, so read the output. Don't just type junk in and, and close your eyes and hope. Faith-based programming never works. Fact check, verify, trust but verify every single thing. Okay, so that's all you need to do to execute homework assignment number 0. I guess there's another note down here you should know. I think I mentioned this in the introduction video when we're talking about handing in your homework. You can hand in multiple times. If you make a screw up right after, that's the nature, right? I just handed it in. The instant I hit enter, I go, oh, I forgot this. I didn't document it, or I didn't put my name in my file, or whatever. That's okay. Go fix it and hand it in again. What'll happen is we'll throw away all your old ones. We'll keep the last 3. Okay? The last 1 that you send us is the one that we're going to grade. Now, if it's an emergency and you handed in something and it was great, and then you handed in a broken piece of junk, and then you deleted all your files, or, some outrageous thing happens, we can at least go back and look at the last 3, but you need to let us know, all right? By default, we're going to grade whatever the last one is you sent in. Okay, so that's how to do assignment 0. That's how to use the machine. It's a demonstration. I just walked through the whole thing. If you don't get an A on this, I can't help you. Okay? Hopefully, everyone better get an A on this program, okay? I don't expect this much help on any other assignment, and by that I mean a complete copy of the source code and a walkthrough of every command, all right? Okay, so there's assignment 0. Good luck. Have fun. I'll see you next time.